Hi, today I'd like to talk to you about fourth on the ESP32C3, which is the RISC-V version of the Tensilica ESP32. It still has the Wi-Fi and Bluetooth, etc. It has the 160 megahertz RISC-V processor, and of course the peripherals and everything else in here. We can just have a quick look at the specs down here, and we see that 160 megahertz, 400k of RAM, and all the different peripherals. Interesting thing about this one though is that the USB is actually dedicated to serial and JTAG, so it's hardwired. You don't need an external USB serial chip. And what we're going to do is look at how we can use this chip with ESP32 fourth, or my variation of it, which is TachyonESP. I'll show you what the advantages are. Because I use Tachyon on propeller, parallax propeller processors, and I've used ESP32 fourth as the base for this one here at the moment. I would really like a totally native version, but here it is. And so we've got this, and by the way, that ESP32, this is what I'm using, the Super Mini module. You'll find them on AliExpress, etc. And at the moment, they're, you can get them cheaper sometimes and in bulk, etc. But it's still pretty good value for money. The ESP32 chip has the 4 megabyte of die stacked flash there on board, and of course there are all the different inputs and outputs, and we can just plug this straight into USB-C, which I have done. So what I'm going to do is show you how to load on TachyonESP and also with the extensions, etc. So first thing to do is come back here. Let's get rid of this one here, and we'll come back here to the INO file, which is used with Arduino. So I'm going to open that up, TachyonESP. I'll show you where to find that later on too. And we can add the extra headers, etc. for these ones here, assemblers, etc. It doesn't really matter. But what I've got is, over here I've got a terminal hooked up. It's right there. The ESP32 is plugged straight in, but I'm going to disconnect the terminal in minicom just with a Control A and a P, and that actually disconnects the port. So this way in my Arduino can come back. And by the way, I'm going to show you about the setup for here too for Arduino. It wants you to update all the libraries. No, because what we want to do is to have in here a ESP32-C3, and there it is. See that version there, 2.0.17? Yeah, don't use the newer version 3s. It's not compatible at the moment. We'll have to work out what we need to do for that, but leave it at that. And so obviously you have the board manager. I'm just using this one here, pretty much any ESP32C3 device, and it's hooked up on ACM0 when it's on Linux. Okay, so there's no actual need for any CH340 chip or anything like that at all. It's just plugged straight into it. That's great. A few things to remember too. When you get this, what you need to do is make sure that you have this enabled, CDC on boot, because I actually use the USB port directly as well in my fourth. So and it's a lot faster than the API version. And of course all this stuff is normal. Don't erase flash unless it's really messed up. And of course over here flash size is 4 megabytes, which is what it is. Now the partition scheme, set this up for over the air, just 2 meg for the app and 2 meg for SPIFs. Right, that's all we need. Upload speed doesn't matter because it's actually using the USB serial JTAG, and there's no UART in between, so that doesn't change anything. So we've got it up here, and we've got a bit of a window for the output, and we're going to do a Control U to upload it, compile upload. Yep, all good so far, just normal warnings and writing it all. This is great, it's what we want. If it doesn't do this, and it should, well, we'll get back to that. Now, come back here, I can release the port here now. Oh, and there's all the error messages, and it's talking to us. Now, what's happening here? It's got some words in it, but this is really the very basic fourth in here. What we need to do is add the extensions. But by the way, we can check little things like this, for instance, that we can put in different formats, etc. and we can even put in date format. So the 10th, the 12th, the 25. Well, in fact, I like this way round, 25, 12, 10. Okay, we can put that in as well, and also character literals, etc. And control literals. Well, you know, we know what's going to happen here. Control J, emit that, and 1, 2, 3, 4, 5, 6, and look at the stack. Here we go. But what we're going to do is enhance it now. We're going to load in these extensions. How are we going to do that? Well, I've got my Visual Code Studio over here, and Visual Studio Code, whatever it's called, I always get that mixed up. And over here I'm going to send a file. I've got a script in here, by the way. Let's have a look at the script. Just S, nice and simple. It just says, look, I'm going to use ASCII transfer. This is in Linux, and just send it without any delays, that file straight through to that device. I'm assuming that's the first device I've plugged in. I've got another script to allow for delays or anything else, but in this case we don't need it. So this is completely completely blank at the moment with extensions. It's only got the kernel loaded in. What I really need to do first up though is, this is the very first thing that goes in and stays in afterwards, and it's a loader. And what it does is it'll load into memory. It will won't echo anything back. It'll just spit out line numbers, etc. It's very efficient, very fast. But to load it in, I probably need a little bit of delay there. I'll just give it 10 just to be on the safe side. There's not much to it, but let's paste it in. Okay. I pasted that in, and now it's gone back to raw input, which accesses the USB registers directly, so it's faster than the API version, which can really miss characters. Now that we've done this, we're going to use the script for sending, which is S, and since it's not in the path of Linux, I'll just type it in here like that. And what do I need? I need extend. That's all I need to do. And there it goes. Now extend happens to be all of that, about 1,000 lines of code, etc. and so on, and that's just gone loaded in. And what does it look like? It's, well, I'm just going to do, it's enable shortcut keys, so lots of keys, everything from the ANSI sequences that we have through to control C's and control Q's, like 1, 2, 3, 4, 5, 6, etc. Control Q will just print out the stack for me. Control C will do a reset. That's what I want back here. Control W will give me words, and notice it detects the actual ANSI terminal, whether it supports ANSI, and what size that terminal is. So words will automatically wrap around. I should have an Xmax in here somewhere. I think it is. Yeah, Xmax, Ymax. And if I change that terminal size, let's make it a fraction larger. Hey, okay. And when I do a Control L, it'll just refresh the display. Xmax is now changed back down, etc. Okay, so I'm just going to make that a bit smaller again, because otherwise it's too large for me. And now I've got extend in there, and extend's got a lot of stuff in there. It's also got all that history stuff in here. I can just go up and down with ANSI keys. These aren't just control keys, these are your arrow keys on your keyboard. Arrow, so if we go up to this one here, Xmax, I'm going to print that one out. I'm going to add to it Ymax. Right, doesn't really matter, uppercase, lowercase. Away we go, nice and easy. I can also do something nice and quick too. If I want to do a do loop, I normally have to put that in a definition, but here I'm just going to put it in brackets. On Tachyon, on the Parallax propeller, it's always in compile mode. Here I force it to compile mode, and this is what I can do with it. I can say 8020 do I emit loop and end of compilation. It's just a temporary compilation. It will execute this and of course release the space back to where it was before. There it is. So that's nice and easy. I can come back and say, well, you know, before you do that, let's put a character return in front of it. So I can go back to insert mode or whatever I need to do, delete things, etc., insert, and away we go. That's nice and easy. Yep. And Control X will just repeat my last line for me. Control X, nice and easy. Very quick to test things out and edit them, etc. And so that's with the extensions on there. Extend does a lot of things. You might see, we'll have a look over here at the editor over here. I have a few extensions in there for accessing 1, 2, 3, 4, 5, 6, 7, 8 for instance. Control Q. I notice the prompts, and if I type in an error, oops, it comes back in red, but it doesn't clear the stack. Beautiful, because I want to know what's on the stack, or I want to reuse it. So this is good. I did a typo and it hasn't wiped the stack for me, so I don't have to type it back in again. Now what I want to do is I have for instance over here I have N1, N2, N3, N4. These are just stack notations, N2 being the over part really, N3 being the third item or pick, you could say. In this case, much easier, faster, and also a number of times I have an address. It might be like whatever the address is, but in this case the second item I can just go into increment it, and so therefore it increments that address. And of course quite a few other things and some notations. I noticed that fourth traditionally has this funny thing of saying print a number, 1, 2, print a number, which is great on the console, but in source code you lose that little dot. So I like to say 1, 2, and in my source code print it. Same with printing strings. I can print hello world, world, like that, nice and easy. And then I decide I'm going to go back in history and put it in a little loop and just do 9, 4, 10 times. So basically 9, 4 next, like that. Well, no, not so good, because now we want 9, 4 carriage return, and away we go. In fact, I'm not even sure I put in special characters in here to allow for, I'll have to check. Just going to see if it does a new line. No, it doesn't. I've got it somewhere. Check again. I'm messing this up now, but that's alright. I thought I put it in there somewhere, but I haven't got it in this one here at the moment. But just to recognise standard escape sequences, whatever they are, I'll do that again. Now I just did a Control S, and that cleared the stack out, and so there's nothing else on the stack. Very good. And words, of course, run as normal. We have different colours. We can go red pen, for instance, red pen, white paper. What's happening here? White paper, print hello, and there we go. And of course the prompts are forcing the colours back again. And what else can we do? Let's have a look at the source code over here. We can do some timings. What I've got in here are I/O operations. I also allow for the Tensilica version here too, by the way. I've been playing with that a little bit, so I've been adding it in, and I'll have to do more work on that. But essentially what happens is that we have bit operations that we can do. We can set a bit, etc., in memory or anything else like that. If there's the aliases I have for print, and 8K bytes is an easy way of saying 8192 K bytes. And emojis, well, I love emojis. For instance, I don't know what we got here. Let's have a look at some emojis. 1E1, for instance, is an emoji. What is an emoji for? Well, it's an emoji for a little shaded circle, isn't it? And A9, that would be an emoji for, I don't know, it's just not allocated, etc. But we can, once again, we can use that little loop idea. Let's just do from 200, 0 do. Hey, this is a great way to demonstrate this too. Basically, just check this for, there's 1F and, I'm going to use an and symbol on this one here, ampersand, because fourth, I was mentioning that before, fourth has a lot of and, or, etc., very verbose words for operators, and for printing and things like that, it has little symbols, and yet normally we use the symbols as operators rather than functions. So I like to reverse that a little bit. I still support the and or and everything else, but I like the 1F and, for instance, here, and that's equal to 0, and if it is, well, you know what we're going to do there, don't you? We're going to do a carriage return, we're going to get I, now, instead of having to worry about how to print this out in hex and badly format it, I just say, look, print this out as a word hex word, or .l for a long 32-bit hex word. Okay, and also print, we'll do this print one here now, and print a little colon space, etc., and away we go. How's that sound? And now emoji should emit what we need it to emit and loop. And once we're done, what do we get? Oh, that was easy, wasn't it? So we've got a few emojis there, and there's many more to it. I won't spit them all out, but that's nice and easy. I could go back in there and say, well, look, you know, I like this, but let's go to 400, up to 400 from 200. All right, away we go. There we go, nice and easy. We can also set a pin high. You probably won't see it here. I'll do it in another experiment where I'll show you the board and what happens when we set a pin high. For instance, an LED will be low, 8 low. High and low normally in ESP32 are just constants, but and on and off, etc. But that's well, actually not on and off, but that's sort of a waste. And what I like to do is just say, if I want the pin to go low, it's low. If it wants to go to an input, it's an input. I can also make a pin of UART, for instance, just very easily, because I have a lot of up in here. You might see over here, besides all the decimal formatting, etc., that's included in here. I'm going to come back to this one now, because I'll just take you back through this formatting numbers. You'll probably see examples of that. I like to have a separate data space. So, you know, normally in fourth you say variable, right? What's a variable? Well, it's always going to be a cell size, 32 bits, okay? So variable Q1, all right? So Q1, where is it? Let's print out a 32-bit address here. It's pretty much right there in code memory. And if we want to write a double into Q1, well, it's going to be overwriting code dictionary space. So what I do is do it like this. I say, look, I only want 1 byte. So I have a byte. 1 byte called a little, okay? And what is little? Well, is it in code memory, or where is it? Well, it is, but it's just in a reserved area. I can go and wipe out little. I can say little for 100 erase. Nothing crashed because it's in data memory. That's good. And of course, when I go another variable here, I'll do 2 bytes this time. 2 bytes being, we'll go Q2 this time. And Q2 is 1 more byte than little. Nice and easy. That's great. And little, let's have a look at it. We've got dump tools in here. Or 0 dump. We can do the same again with a dump long or dump. You won't see any ASCII versions. I can do ASCII and different things of dump words. Okay, just to give you an idea. And where are we now? Here. So here I can go 100 dump long, or dump with the ASCII included into it. Nice and easy. This is turning into a bit of a long video, but maybe if you're still here with me, you've already seen how you can load this on, and you've already loaded it on, and you've come back and you want to see what else you can do. Well, that's good and fine. I might edit the video to help you out, but what I'm going to do now is put in another one just like extend. I can show you a bit more about all this, how I can access registers. I should actually show you about timing. How about that? Let's try this timing thing. What I've done is access the system counters which run at 16 megahertz. 2 timers there. I access them directly, and then I built in timing tools. The idea is that we can come along here. You can't really time anything in the normal interpret loop, because the interpret REPL loop is inefficient. You know, I'll demonstrate this in a minute. For instance, if I do lap something, I can say lap 1, 2, 3, 4 plus, and put a lap around it, so it will just latch on each time, and then work out the difference between these 2 timings and print that out in nanoseconds or microseconds, etc. So here we go, 375. Let's repeat that with the Control X, 400. So there's a bit of variation in there with